Okay. I don't know if these things are charged up, but let's give this a shot. Okay. So where am I at here? Okay. The first thing I'd like you to realize is math problems are really efficient, and in some ways, I shouldn't say laziness, but this efficiency or willingness to write as little as possible and do as little as possible has kind of shaped the mathematics that we have right now. There's a couple things you probably haven't given a lot of thought to, but way back in the day, mathematician says, okay, what I must do on this problem is I must take 7 and plus 7 and plus another 7, and I'm going to take plus 7 and plus 7 and plus 7 and plus 7 and plus 7. This is awful, writing this many plus 7s. So they found a faster way to write it. What do? 7 what? 7 times 8. That's a shortcut for 7 plus 7 plus 7 plus 7 plus 7 plus 7 plus 7. Okay? And another thing is they're like going, oh, on this problem I must go x times another 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 x. They found a shorter way to write this. What did they do? X to the 6th. Exponents were simply a way to write things quicker. Okay? And mathematicians, when they were first solving things, they figured out factoring. They had the square roots. And they're like, okay, how can I do this? They completed the square. And they, just like you guys, when they got doing problems like these, they're like, oh, this is terrible. I don't want to do this all the time. Okay? So they're like, okay, since it's a process that's the same every single time, they said, let's make a formula. So like I said, don't write this down, but we're going to show you where this comes from rather than just give it to you. Let's complete the square. In terms of A, B, and C, if I complete the square in terms of A, B, and C, then I will have a formula that tells me what my answer is going to be, and I don't have to go through this whole yucky process. So what should I do first? Minus C. So I'm going to go A x squared. Okay, I could do that first. But there's something else I need to do. I need to divide by A. Okay? So I also need to do this. It doesn't matter the order that we do those two things. Okay? But I've got to get to that point. Now what? Half. So we got to find half. What's half of B over A? B over 2A. Okay? Half of. So 1/2 times. So I get B over 2A. Now what I got to do to B over 2A? I got to square it. Add it to both sides. So what is B over 2A squared? Well, first of all, what goes on the top? B squared. What's on the bottom? 4A squared. Because if I take this times itself, I get 4A squared. What I'm trying to do is I'm trying to introduce you to kind of the elegance of some mathematics and where it comes from, rather than just have skills. I want you to appreciate what we're doing. Okay, so in order to add these two things together, what do we got to do? Common denominator. My common denominator between a 4A squared and an A. Yeah, I'm going to need a 4 and an A squared. So let's go back up here. What do I have to multiply top and bottom of this thing by to find my common denominator, which is 4A squared? I got to go times 4, so I get my 4A, but I need something else. Not a squared, but I need another A. Okay, so let's think about it. Let's take a deep breath. I move my C over. I divided everything by A. Half of B over A is B over 2A. Squared that, added it to both sides. Found the common denominator by multiplying by 4a. So now I'm going to rewrite this in a certain way. I like my b squared first. And this is going to be minus 4ac. Okay? So let's keep going with the algorithm. What do we do next? Square root both sides. Okay? So I have a plus or minus. What's the square root of 4a squared? 2a. So now all we have to do is subtract b over 2a. And we get negative b and the square root of b squared minus 4ac on top and 2a on the bottom. 3.6 quadratic formula. That's where today starts. Okay? That you should have down. Because you're going to use that and use it and use it and use it. From here, we're going to do 4 examples, and then we will turn you loose. Negative b plus minus square root of b squared minus 4ac all over 2a. We should have races to see who can say it fastest. Oh, really? Your brother a real fast talker?
No, he had to memorize it.
Oh, really?
And got theirs.
Good. Yep. Saying we'll do the same thing here. There will be one day where you won't get in the room unless you are able to recite that.
Yeah, it was said that we either had to memorize it by Thursday or we have to sing the song in front of the entire class.
Oh, there you go. What song was it?
As we just sing the formula.
Oh, the formula. Oh, gotcha. Actually, there was one time. This is where I actually would not let kids in until they could recite this. And then, they get it wrong. They have to go back and then go to the back of the line and then get it wrong. I had a young lady that, I'll never forget this. She used to be very successful, but this thing she couldn't get. And I was like, no, try it again. And just the stress of that kind of broke her down. So I'm like, you kind of got to be careful when you put kids on the spot and when you don't and this, that, and the other because some kids can handle stress more than others. Okay, so here we go. We're going to do, what did I say, 4 examples? Let's go. So here we go. 2x squared plus 8x minus 34 equals 0. Okay? Okay. Before we do anything, we should make our lives as easy as possible. Going like the old traditional mathematicians. They're like, let's make this easier. So what can I do to make this easier? Divide by 2. Yeah, everything's even. So let's divide by 2. I'm going to divide everything on the left by 2. Everything on the right by 2. I get x squared plus 4x minus 17 equals 0. Okay. I have just a couple things that I think are really, really, really important with this. I don't care if you write the values of A, B, and C down. If you want to, that's great. If that helps lead you to less mistakes, that's fine. But I realize that there's a lot of people in here that don't need to do that every time. I'm not going to force that on you. But when we solve this, I want you to watch your notation. The answer is x equals... Then we're going to do the opposite of b, plus minus the squaring. I hope you do that in your head. Because if you don't do that in your head, you're going to make mistakes. At least some of you might make mistakes. Like say if b was negative 2, if you grab your calculator and square negative 2, first of all, you're silly, but you might your calculator will probably tell you negative 4, and you'll make mistakes. So try and do the squaring in your head. But this next part, minus 4 times 1 times negative 17. That I want written out.
How did you get 16?
Because 4 squared.
Oh, okay.
Great question. Great question. I need to foster more people asking questions when they aren't quite sure about something. Because my seniors do a great job with it. And on the bottom, it's over 2. But the reason why we write this first part out, this underneath here, that's the most important part of this equation. okay, is if you write this out, you'll see that this negative is going to cancel with that negative, and that turns it into a plus. Otherwise, sometimes people will just, that's the most common mistake. So to avoid that, write it out. So we get x equals -4 plus or minus the square root of 84 all over 2. Okay? So now we're going to slide over to the side and go ahead and do the square root of 84 simplification. Square root of 84. 4 goes into that. Without your calculator, how many times 4 go into 84? 21. Nice job. Okay, because 4 goes into 8 twice. 4 goes into 4 once, so 21. And square root of 4 times 21, well, square root of 4 is 2. So 2 squared, so 21. Okay, a couple things I need to emphasize. Simplifications. We're not done yet, but if I go back, can I cancel this 2 with the 84? No. One of them is under a square root. It's protected. I can't do that. If there was a square root of 2 on the bottom, then I might be able to do something. But, okay, wait a minute. Can I just cancel this 2 with the 4 and then call it good? No, because everything on the top wants to be divided by 2. Not just the first term, everything wants to be divided by 2. So now what I'm going to do is I'll take a look at, okay, that is even, that is even, that is even, and I need to divide this first term by 2 and this last term by 2, and then I can rewrite my answer. So I get -4 over 2, gives me -2, plus or minus square root of 21. There's my solution. Okay.
What happens with your 84? You just
84, I broke it down up here. Okay. I'm going to teach you something that is coming up. This 84, that's called my discriminant. Discriminant. It tells me what kind of answers that I'm going to get. Okay? This one right here, since that could not be square rooted real easy and there's a square root in my answer, I got 2 solutions that are called irrational. Irrational numbers are numbers that go on forever without a pattern. Okay? If I would take a look at these answers, it's kind of like pi. The decimal goes on forever. Okay? We're going to talk about discriminant later on. Do another example. Where am I at? There I am. Okay. (9x squared plus 4 equals -12x). What do you think I should do first? I need to add 12x. I've got to get it set equal to 0 first. That's my absolute first thing. 9x squared plus 12x plus 4 equals 0. Okay. Now, personally, I would hope that you would see a little pattern we got going on here, but I'm trying to build something else. Let's go ahead and do quadratic formula with it. Go. Quadratic formula. X equals when you get the value of your discriminant, I want you to compare it with your neighbor. And make sure you got your discriminant right before you try and simplify anything. Come on. Come on. Come on. Compare your discriminants, please. Okay, what's your discriminant, folks? What do you get? 0. Hopefully by this time you guys would all be going 0. Okay, so let's take a look at it if it's giving you some grief. I got my negative b, the opposite of my b, plus or minus square root of 12 squared, minus 4 times a times c. 4 times a times c. 144 minus 144 gives me 0. Okay. So in this one, I want you. We're looking for some patterns here. My discriminant was 0. How many answers did I get? I just got one answer. It's what's called a double root, but we're not going to visit with that now. I get one solution, and it is rational. Okay. What makes this rational? Well, what's the main word of rational? Ratio. Fraction. It can be written as a fraction. You get one rational solution. Okay. Here we go. Let's do another one. Five x squared minus 13x minus 6 equals 0. Go ahead. You can do that one on your own. We've had enough practice now. You can just go ahead and start rolling through. Negative b plus minus square root of b squared minus 4ac all over 2a. Okay. Okay. So let's take a look. So what did you get for your discriminant? 289. So just 289 is a discriminant. Okay? You probably don't recognize it, but 289 is a special number. It's a perfect square. Okay? But Zach, let me add to this. If it's negative and you're going to square it, forget about your negative. So when you're squaring a negative, drop the negative altogether, because a negative squared is always a positive. Negative 10 squared, 100. Negative 4 squared, 16. Negative 5 squared, 25. Your answer is always positive. So, but otherwise, yeah, you do have to put it in parentheses. Okay. So then we end up with these for solutions. Okay. Okay. So that's 17. So I end up with 13 plus 17 is 30. 13 minus 17 is negative 4. So then I just simplify down to 3 and negative 2/5. Okay. So this case, let's make a summary here. If it's a perfect square, we get 2 rational solutions. Okay? And that is, we've got one more, but yeah. Kind of based upon a couple things I saw there, we're going to do one more of these. 9x squared minus 3x plus 18 equals 0. It's already said equals 0. What should you do to make your life easier? Divide by 3. Yes. Always divide by something if you can. Okay? So in this case, we're going to go 3x squared minus x plus 6 equals 0. Go for it. I like it when you guys compare your answers with those around you. I like when you guys help each other as well. I've seen a couple examples of that. That's awesome. Okay. So on this one, I got my discriminant to be negative 71. Okay? So when we go ahead and rewrite this, we get 1 plus or minus I squared to 71 over 6. And I know you guys are like, why? But mathematical convention tells us to do this. 1/6 plus or minus the square root of 71 over 6, I. That is the correct way to write that. Okay? So what we've got here, so when this is negative, then we have two, bless you, imaginary solutions. Okay? Okay. So what we're going to do is we're going to summarize what's going on with these solutions real quick. Okay? I have already written it here, there, and everywhere, but I'm going to put it in a little chart here. Again, discriminant. Equals b squared minus 4ac. No square root. Main word is to discriminate. Okay? Like to discriminate, I might look and say, okay, Owen, he's a male. I know he's going to have sloppy handwriting. Okay? Is that true?
Yes.
Those are probably maybe not fair things to say, but those are kind of judgment calls, so we try not to make those too much, of course. But anyway, there's a lot of situations there where when we talk about if we're trying to discriminate, that means we're trying to tell things apart. It doesn't necessarily mean that we're making bad decisions. We're just trying to say, okay, this has this trait, so this is what's going to happen. This has this trait, so this is what's going to happen. So if we're going to use some geometry lingo here to save us some time. If b squared minus 4ac is less than 0, that tells us we have two imaginary solutions. Okay? If b squared minus 4ac equals 0, that was where we had
What is that? IMAG?
imaginary.
Oh.
Here where we had 0 underneath, we end up with one solution. So you get one rational solution. If b squared minus 4ac is a perfect square, yeah, good. Good job, Holly. That was you, right?
Yeah.
Two rational solutions. What's weird is in my house, out of the three people that are usually together, myself, my mother-in-law, and my wife, I have the best hearing of all three of us, and I'm the one that goes to concerts all the time. It's weird. And my wife will be like, what? I'm like, oh. So anyway, protect your hearing. Trust me, trust me, trust me. Okay? If b squared minus 4ac is equals 0, is greater than 0, but not a perfect square, so in other words, I can't square root it. It's going to have a square root when I'm done. I will have two irrational solutions. Okay? And while you guys really haven't seen the full concept at play yet, this actually proves to be pretty useful. It not only tells us, whether it's going to be imaginary or real or something like that, but it'll also tell us in this case, I'm going to put here, that it'll factor. Okay? That we could have factored it instead. Okay, I got one last example I'm going to do, but we have like 15 minutes. Diving. Diving. Our example today is going to be with diving. Okay? I remember at my high school we had a swim team and we had a diving team. I was at a Class A school, so it's a little bit bigger. We had our own pool at the school. It was awesome. It was great. Anyway, so I was on the diving team as a freshman because I tried a little bit of everything to find out what I was good at, and it ended up that I was not good at diving. Okay? You know, most of the scores that other people got on their dives were like 4s, 5s, 6s, 7s. Mines were like 2s and 3s. Okay, that's just how it was. I remember one competition, I did a dive, and the judges looked at each other, and they didn't want to score it. It was that bad. And then one judge says, just give him 1s. So they all gave me 1s. I was like, yay, you know. And I remember one time I did get a dive, it was like an inward pike or something like that. And I was getting like in the 5s, and all the kids were like, yeah, Rexroad, all right, good job. Another thing I remember is we had one kid cut his head on the diving board. He did a 2.5 and caught his head underneath. Just blood everywhere. But anyway, that's a whole other story. Okay? So, but diving, I gave it a shot, and it wasn't my cup of tea. So the height of a dive in this particular situation, negative 4.9 t squared plus 2.5 t plus 10. This is just an equation that you would be given like on a word problem. Okay? You guys have taken physical science. Who was your physical science teacher? Okay, so a couple different ones. So you guys have dealt with some minor physics already. Let me just show you where these numbers come from. This is where you started from. This is your initial height. This is your initial velocity in the upward direction. And this one right here, anybody know what this is because of? It's negative, that's my hint. Going down, but why? Gravity. This is gravity. So this is where you started, your impulse going upwards, and that's gravity pulling you back down. But that's really not important for understanding this problem totally. Okay? So if I was going to do this, I'm going to smoke through this really pretty quick here. And if I wanted to know when will they hit the water? Well, what's my height when I hit the water? 0. So we'll just use quadratic formula. So here we go. T equals negative 2.5 plus or minus the square root of 6.25 minus 4 times negative 4.9 times 10 all over negative 9.8. Negative 9.8, that might look familiar if you've taken physical science before. That's the force of gravity. This is half the force of gravity. This is the full force of gravity. Negative 9.8 meters per second per second. So this is measured in meters. So T is equal to, I'm going to try and save us some time here by getting my past notes so I don't have to recalculate everything. Here we go. So if I go ahead and do this, I get negative 2.5 plus or minus the square root of 202.25 over negative 9.8. Okay, let's go ahead and do this again. Negative 2.5 plus or minus 14.22 over negative 9.8. There's a couple reasons I'm doing this problem. You just bear with me. Do I want my answer to be positive or negative? Positive, because time. You know, we're not looking backwards in time. We're looking forwards in time. From the time they take off, how long till they hit the ground. So then on this case, I've got two choices. Should I calculate the plus or should I calculate the minus to get my answer that's going to be positive? The minus, exactly. Good job. Why? Because I'm going to get a negative on the top divided by a negative. That'll give me a positive. So in this case, if I grab my calculator and do this, I get 1.71 seconds. Okay? So that's when they're going to hit the water. Quadratic formula is used in physics a lot. I do want to show you something. The graph of this would look like this. What shape is this? It's a parabola. So that right there is 1.71 seconds. If my parabola went backwards in time, this would be 1.2 negative. And there's a very important point here. The highest point, what's that called? Vertex. How do we find a vertex? Okay. This has been from A couple weeks back. But come on, somebody here can remember how to find a vertex. Negative b over? You're awesome. Good job. So how do I find this? Negative b over 2a. Okay? So I've done the work here, and I found out that this is at 0.26. So all I got to do is go back here, negative b over 2a, and I get 0.26. How would I find out how high they went? What would I do with the 0.26? Plug that in for t. And then I can do that in my head, and I get 10.3. Not really. You know that. Okay. I did it last period. So this is one of the things that this book misses out on, is they don't do any review at all, because this is a great opportunity to recycle something we've done before. Okay? So it's the math world and physics and science all tied together. Okay. So today we are going to have an assignment that is due on Friday. And let me see if I can find out a good place where I wrote that down, because I just don't like to rewrite things a bazillion times. There's your assignment that's due Friday. Go. Thank you for your patience. I appreciate that. I appreciate the respect of you doing that. Sweet, sweet, sweet.